So in the screen test, the syllabus is based on what? Gaseous state and solutions lesson. These two chapters. Okay. So now from that, first question is that which of the following represents largest pressure? Okay. So among the given options, which is representing the highest pressure they are asking here. So here 1 atm, 1 atmosphere. So 1 atm is greater, 1 bar is greater. 1 atm is greater than 1 bar, we know. Okay, and 1 bar is equal to generally 10 power 5, 10 power 5 pascals. But here they give 10 power 3 pascals, they give 10 power 3 pascals, they give. So it is less. So here it is less than 1 bar here. And 10 power 5 pascal is equal 1 bar, we know. And also what now here 1 atm is equal to 1 atm is equal to 14.7 psi. Psi stands for what? Pounds per square inch. Psi means what? Pounds per square inch. Okay, so pounds per square inch, 1 atm only greater here. 1 atm is equal to 14.7 psi. So from this we can understand that 1 atm is highest pressure. 1 atm is representing what? Highest pressure. Next, a gas occupied a volume of 250 ml. So volume is given to you. A gas occupied how much volume? 250 ml volume and 700 mm pressure. 700 mm of mercury, millimeter of mercury. So pressure is given to you. Okay, and what temperature here? T is equal to 25 plus 273. So it is 298. So 298 is what now here? The pressure, Kelvin. So Kelvin temperature, temperature. Kelvin temperature is 298 Kelvin. Pressure is how much here? 700 mm. 700 mm means what now here? 700 by 760 atm you can take. But options given what now here? Options are given in millimeter. So pressure, let it be in millimeters of mercury. So volume is given, pressure is given, and temperature is given. What additional pressure is required? What additional pressure is required to reduce the gas? To reduce the gas to volume, okay, of its 4 by 5 of its original volume, initial volume, okay, at the same temperature. So now what additional pressure is required here? What additional pressure means what? P2 minus P1. So additional pressure means not P2. So P2 minus P1, the difference. So how much difference of pressure should be required to reduce the volume to reduce the volume to 4 by 5. So reduce the volume 2 means here what we have to understand, V2 should be 4 by 5. 4 by 5 of what? V1. V1 how much here? 250 ml. So 4 by 5 of 250 ml will be the volume, final volume. So V2 is equal to what now here? 4 by 5, 4 by 5 of 250. So like that we have to understand concept here. So it's about what now here? The initial volume 250 ml. Initial pressure 700 mm. And final volume V2 is equal what? 4 by 5 of 250 ml. Okay, and P2 we have to calculate first here. So generally at same temperature, what formula we have to use here? What is the relation between pressure and temperature? Generally pressure and volume inversely proportional. Volume is inversely proportional to pressure. It's constant temperature. That's what we have to understand here. P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2. First find out P2. P2 is equal P1 V1 by V2. Right now. So after finding P2, P2 minus P1. P2 minus P1 will be answered here. They asked about what additional pressure should be applied here, should be used to reduce the volume. That's why here P2 minus P1 is equal to what they asked here. That will be 175 mm. Is that clear, ma? You should not take P2, remember, P2 minus P1 we have to take. Next, 43. Which of the following volume, okay, temperature plot, volume temperature plot. So volume temperature plots represents the behavior of 1 mole of an ideal gas. So 1 mole means number of moles, how much here? Number of moles given 1 mole. Ideal gas equation what? PV is equal to nRT. PV is equal to 1 RT. Here N is what? 1 mole they give here. PV is equal to RT here. Is that clear? And at 1 atmospheric pressure, 1 atmospheric pressure means P is equal to 1 atm they give. So pressure is equal to 1 atm. Is that clear, ma? Now here R is anyhow constant. Now what is the relation between volume and temperature? Directly proportional to each other. Volume is directly proportional to temperature. Okay, V1 by T1 is equal to V2 by T2. So what is the formula here? V1 by T1 is equal to V2 by T2. It is what now here Charles law equation. So from this Charles law equation, if you apply, this only will be applicable here. So here it is what now here V1 is what here 22.4 liters, and T1 is what now here 273 Kelvin they give, and it is what now this 30.6 is what V2, and 373 Kelvin is what T2. Okay, now V2 calculate first here. V2 should be calculated. If you calculate V2 should be equal to what now? 30.6 liters. Then we have to apply this V1 by T1 is equal to V2 by T2, and V2 value you calculate here. V2, if it is equal to 30.6, this will be answer. If V2 is equal to 36.8, this will be answer. If V2 is equal to 28.6 liters, it will be answer like that. So it will be correct for this here. So V2 will get 30.6 liters. If you apply the formula, V1 by T1 is equal to V2 by T2. Is that clear? Next. Here, according to Graham's law, according to which law? Graham's law of diffusion. At a given temperature, the ratio means constant temperature. Here, temperature is constant. The ratio of the rates of diffusion, the ratio of rates of diffusion of two gases, RA by RB of gases A and B, is given by what now here? What? So they asked about what now here? They asked about R1 by R2 is equal what? So RA by RB is equal to, generally what is the formula? P1 by P2 into under root M2 by M1, under root M2 by M1, molecular mass here. M is what? Molecular mass. And under root what? T1 by T2, under root T1 by T2. Anyhow, temperature is constant they give. So T1 is equal to T2. Temperature is constant they mentioned here. So T1 by T2 no need. Root square root of T1 by T2 no need. Now here RA by RB is equal to P1 by P2 means PA by PB. Then under root MB by MA. Next TA by TB. Like this we are taking form. So this formula will be answering. So here the square root of MB by MA means so this only. So it is nothing but square root of MB by MA. Square root of MB by MA we can write like this here. MB by MA to the power of whole power 1 by 2 we can write. So it's about what now here the 44th one. 44th one answer what now? Third option. Okay, na? Next. So next one here, for gaseous state, if most probable velocity, most probable speed is denoted by C star, it is what now here UMP, most probable velocity, and average velocity is this one here, average velocity, and RMS velocity this one, URMS, root mean square velocity C. In that case, for large number of molecules here, for the large number of molecules of a given gas, ratios of the speeds will be what? Okay. Now here, C star is what now here? Most probable, 1. And C is what now? C bar is what now here? C bar is what? Average velocity, 1.128. What I corrected that day in the question paper I have corrected now? 1 is to 1.128. 1 is to 1.128 is to 1.225. So this will be answer here. Anyhow, in question paper, physically it is corrected here. So 1 is to 1.128 is to 1.225. So this will be right answer. Is that clear? Next, if the average velocity of nitrogen molecules is 0.3 meter per second, so it is what average velocity. Average velocity of nitrogen molecules is given to you at given temperature. T1 temperature is mentioned here. So it is U1 and T1. In that case, the velocity of 0.6 meter per second, it is U2. U2, average velocity U2, will take place at what temperature? At what temperature means T2 is what? Okay. Now we know formula here. U average is equal to what now generally formula? Under root 2 RT by M is what? Most probable velocity. Under root what here? 3 RT by M is what? Under root 3 RT by M. It is RMS velocity. And that if you take what now here in any case what here in any molecular velocity, U is directly proportional to square root of T. Okay, square root of T here. Like this. Now if you take U1 by U2 velocity is equal to what now here? Under root T1 by T2. Now U1, U2 given to you. U1, U2 given. U1 is given, U2 is given. And T1 is given. T1 is given to you. T1 we have taken Kelvin temperature. 27 degrees Celsius plus 273 will be in Kelvin. Now U1, T1 given, U2 given to you, T2 we have to calculate. T2 in Kelvin temperature we have to calculate. So like this, U1 by U2 is equal to what? Under root T1 by T2. Okay. So it is about what now here? The velocities, means the concept of molecular velocities. Next here, compressibility factor for hydrogen behaving as real gas is for hydrogen and for helium. Z means what? Compressibility factor. Z is what here greater than 1. Z is greater than 1. And what is the formula for Z generally? PV is by nRT, na? So PV by nRT. PV by nRT Z here. So for the Z to calculate, PV by nRT should be greater than 1 for hydrogen gas and for helium gas. Okay, so here it will be 1 plus something means for greater than 1. 1 plus something means for here greater than 1. Okay, for hydrogen, the molecular size will be very less. Molecular size will be very less. That's why when you compare with the large volume of gas volume, we can neglect what? We can neglect what? The volume of the each gas molecule of hydrogen can be neglected. We have taken various conditions how to derive what here this condition. Z is greater than 1 or Z is less than 1. These are all things we can calculate. A Z value will be 1 plus something here. So it will be what now here? Greater than 1. Z value is greater than 1 for what? Hydrogen gas and helium gas. Is that clear, ma? Next, 48th one. The Henry's law constant means Kh for the solubility of nitrogen gas in water. Nitrogen gas in water at given temperature is 1 into 10 power 5 atm. So it is what now Kh given. What is given? Henry's law constant is given. It is what temperature. At the given temperature, Henry's law constant for nitrogen gas is given. Okay. Now the number of moles of nitrogen from air. The number of moles of nitrogen from air. Air is a mixture of what? Nitrogen, oxygen, CO2. So in air, there will be only nitrogen or many gases, different gases will be there. Now we can calculate mole fraction of nitrogen. Mole fraction of nitrogen means what now here? Number of moles of nitrogen divided by total number of moles. Total number of moles of air. Total number of moles of air and number of moles of nitrogen. This ratio will give what? Mole fraction of nitrogen. But generally 80% will be there, now 78% of nitrogen is there in the air. So 80% if you take, 80% means 80 by 100. 0.8 will be what? Mole fraction of nitrogen in air. So it is approximately equal to what? 0.8 we take, mole fraction of nitrogen. So this, how many moles of nitrogen gas is dissolved in water? How many moles of water given? 10 moles of water. At same temperature. Temperature is kept constant. Initial and final same temperature maintained here. So it's constant temperature, 10 moles of water is taken. And in this 10 moles of water, what is dissolved? Nitrogen gas is dissolved from air. Okay. And what is the pressure given? Total pressure is given 5 atm. So what is P total given? P total is equal 5 atm. Total pressure is given to you. Henry's law constant is given. Henry's law constant is given. And whenever they mention nitrogen in the air, we have to take mole fraction of nitrogen in the air. 80%. 80% means 80 by 100. That is equal to approximately 0.8. Okay. Volume fraction is nothing but mole fraction in the air for nitrogen. So 80% means 80 by 100. 0.8 we take here. I will see this. Now see here. First one what now here? P nitrogen is equal to Kh into X. Nitrogen means for a partial pressure of nitrogen. So partial pressure of nitrogen. Partial pressure of nitrogen is equal to Henry's law constant into mole fraction of nitrogen in the air. So mole fraction of nitrogen. So mole fraction of nitrogen in the air is equal to what now here? 80%, 80 by 100. So 80 by 100 means approximately what? 0.8. So 0.8 is mole fraction. And here Kh is what now? Henry's law constant. And also P nitrogen is equal to mole fraction of nitrogen into total pressure we can take now. It is Dalton's law. According to what now here? Dalton's law. So partial pressure of nitrogen is equal to what? Partial pressure of nitrogen is equal to mole fraction of nitrogen in the air into total pressure. Is that clear, ma? So here what we have taken now here? It is partial pressure of nitrogen is equal to mole fraction of nitrogen in the air into total pressure. Total pressure is given to you what now? 5 atm. Mole fraction is equal to what in the air? 0.8. So 0.8 into 5 is equal to 4 atm. It is what now? Partial pressure. So partial pressure of nitrogen, how much now here? Partial pressure of nitrogen is equal to 4 atm, we remember. So this partial pressure of nitrogen P 4 atm is equal to Kh into mole fraction in air. In what here? It is what now? So this is in water. Mole fraction nitrogen in water. In water is equal to what? That means the solubility of nitrogen in the water is equal to what? So nitrogen solubility in water is equal to what they asked here. Now Kh is given to you and Pn2 we got 4 atm. How much we got? 4 atm. How we got this 4 atm concept here? From air 0.8 fraction of nitrogen into total pressure of air 5 atm is equal to total 4 atm we got. So now here what is this here? Pn2. Pn2 what now? 4 atm is equal to 10 power 5 atm. 10 power 5. What here? This one here. What is this here? Kh value. What is given? Kh given. Kh of nitrogen given 10 power 5. Partial pressure of nitrogen 4 atm we got. And mole fraction of this nitrogen is equal to what? A mole fraction of nitrogen is equal to 4 by 10 power 5. 4 by 10 power 5. 4 by 10 power 5 means what? 4 into 10 power minus 5. So mole fraction of nitrogen we got what? 4 into 10 power 5. Right? This means that in 1 mole of water, in 1 mole of water, a number of moles of nitrogen dissolve how much? 4 into 10 power 5. It is per liter. So per 1 liter, 4 into 10 power 5 moles of nitrogen is present, solubility. Solubility is what now? Moles per liter. So now here solubility is equal to 4 into 10 power 5 moles per liter. These many moles here. So moles per liter we have to take solubility, remember. This means that in 1 mole of water, number of moles of nitrogen dissolved is equal to 4 into 10 power 5 moles. Then in 10 moles of water, how much? Okay, 10 into 4 into 10 power 5 minus 5. So 4 into 10 power minus 5 into 10. That is equal to 4 into 10 power minus 4 is what now here? Number of moles of nitrogen dissolved. Okay, so 10 moles of water contains what? 4 into 10 power minus 4. So what is the answer here? What is the answer? This one. 4 into 10 power minus 5 minus 4 moles. These many moles of nitrogen dissolved in 10 moles of water. Is that clear, ma? Take screenshot of this. Take the screenshot of this. Okay. So next, which of the following contains maximum number of nitrogen atoms? Atoms they ask, remember, nitrogen atoms. Number of atoms formula what? Number of atoms is equal to number of moles into Avogadro number. Number of moles into what? Avogadro number. Avogadro number is what? 6.023 into 10 power 23. It is number of molecules into atomicity. So atomicity means what now here? Number of atoms in one molecule. Atomicity means what? Number of atoms in single molecule. So now here number of moles into Avogadro number will give number of molecules. Okay, number of molecules into atomicity will give number of atoms. Okay, so here it is given what now? 22.4 liters. Okay, of nitrogen at STP. What is atomicity of nitrogen here? Atomicity is what? 2. For in each molecule, how many atoms there are? 2 atoms. So atomicity 2 here. Now number of moles, 22.4 liters at STP will be equal to 1 mole here. How many moles it is? 1 mole. So number of moles 1 into Avogadro number into atomicity 2. Like that we have taken number of atoms. So that's maximum number of atoms. Maximum number of atoms. So this way we have to understand. Okay. Here in one molecule, 2 atoms of nitrogen there. Here in one molecule, 1 atom is there. In one molecule, 1 atom is there. Here 1 molecule, 1 atom is there. So the same thing we have to do it. So number of moles into Avogadro number into atomicity will give number of atoms. So this formula to be applied, the answer is first option. Next, the correct order of inversion temperature, Boyle's temperature, critical temperature is what? So in this here, critical temperature is less than, Boyle's temperature is less than inversion temperature. It is inversion temperature. What is the formula of critical temperature? 8A by 27 RB. And TB is what? A by RB. And TI is what? 2 into A by RB. 2A by RB. So 1 into A by RB, here 2 into A by RB. In this case, 8A by 27 RB. So in this way, we get what now here? Third option. Next, the temperature at which both centigrade and Fahrenheit temperatures, both are same, is what? Minus 40 degrees Celsius. At minus 40 degrees Celsius, both centigrade and Fahrenheit will be same. Okay, now centigrade Celsius is equal to what? 4 by 5, 5 by 9 into what? F minus 32. Na? So from this, if you substitute what now here? Minus 40 degrees Celsius. Minus 40 degrees Celsius. It will be same here. Now centigrade temperature and Fahrenheit temperature will be same at this temperature. So this conversion factor we have to use here. Next, at low pressures, okay, volume is large enough. Volume is large enough to neglect what now here? To neglect B. B means what more? B means the size of the molecule or the volume of the molecule. Volume of each molecule is B. So here at low pressures, when pressure is low, volume will be large enough. The volume will be large enough. Volume of gas will be large enough to neglect what? B. So B should be neglected. In the equation of Van der Waals equation, what can be neglected? B can be neglected. So B we did not write. Actual equation what? P plus An square by V square. P plus An square V square into V minus NB is equal to nRT. It is what? Van der Waals equation. In this Van der Waals equation, what we can neglect? B can be neglected. If number of moles is 1, okay, if N is equal to 1, if N is equal to 1 and B is neglected, then B won't be there, N won't be there. Then here in place of V minus NB, we write V. Okay, V here. Okay, and P plus An square by V square. It will be P plus A by V square. Because N square is 1 square here. N square is 1 square. So like that, what can be neglected here? B can be neglected. Because the volume is large enough to neglect what? B. B need not to write. B need not to write. So then we get what now here? Z value less than 1. Z value less than 1 at low pressures. Z value less than 1, compressibility factor less than 1 means it is what now? It is what? Negative deviation. Negative deviation. Is that clear, ma? So you take here P into V PV, P into V PV plus A into V by V square, AV by V square. AV by V square means what? A by V will come here. A by V. Okay. So A into V, AV by V square. V get cancelled. A by V will be there. Is equal to what now here? RT. Is equal to RT. After that, divide each term by RT. By RT. By RT. It is 1 RT by RT, 1 on here. So PV by RT means Z only. So Z is equal to RT by RT 1. Here A by RTB will go that side here. So A by RTB. Like this here. So Z value is equal to 1 minus something. 1 minus some value is there. So it will be Z value less than 1. So in this way, we have to take it what now here? At low pressures, Z value will be less than 1. So negative deviation will be there here. Next, the weight of H2C2O4 to H2O. It is called oxalic acid. What is called? Oxalic acid. So the weight of oxalic acid required to prepare 500 ml volume is given here of 0.2 normality given. Solution is what? So normality is given and weight of oxalic acid they're asking here. So what is the formula of what is the formula of this normality relation here? 53 take. So normality is equal formula what? Weight by gram equivalent weight into 1000 by volume in ml. Volume in ml. So volume in ml, how much is given? 500 ml volume is given. And normality given to you. Normality is given and volume is given. And the gram equivalent weight we have to understand. So gram equivalent weight of H2C2O4. H2C2O4 to H2O is equal to gram molecular weight 126 by 2. N factor 2. So gram molecular weight by N factor will give what? Gram equivalent weight. So N factor of oxalic acid is what? 2. So 126 by 2 will be 63. So 63 is what now? Gram equivalent weight. We know this one. So gram equivalent weight we know 63. Normality given, volume in ml given, weight they asked here. Weight is equal to what? So weight will be 6.3 grams. Next, what is the volume in liters of 0.1 molar H2SO4 required? So molarity given to you, and N factor of normal sulfuric acid is what? 2. Therefore, normality is equal to 0.1 molarity into what? N factor. N factor is what? 2 for sulfuric acid. So 0.1 into 2, 0.2. So normality of H2SO4 is given what? Indirectly 0.2 normality given. So 0.2 normal. And what is the volume in liters? So V is equal to what? Volume in liters, they ask. Normality given 0.2 normal. Required to completely neutralize 1 liter of 0.5 normal NaOH. Now normality is equal to what now here? Normality is equal to molarity into N factor 1 only here. N factor 1, 0.5 only. 0.5 normal is given here. So 0.5 normal is what? N factor of this one here. So 0.5 normality given, 1 liter is given. So complete neutralization formula what more? For complete neutralization formula what? It will be N1 V1 is equal to N2 V2. So for this 55 what we have take? N1 V1, just wait. So N1 V1 is equal to N2 V2. N1 V1 N2 V2. So this formula is. Okay. So from this what we have to get? V1 we have to get for acid. For acid normality given, V1 we have to get. Answer will be what now here? 2.5. Okay. So N1 V1 is equal to N2 V2 we get. Here N1, you take this one, it is N2 and it is V2 and V1 they asked here. Okay. Next. 3.42 grams of substance. So it is weight given. So weight of substance given. And molecular weight is given. Gram molecular weight is given. And it is present in 250 grams of water. So weight of solvent, weight of solute, molecular weight of solute. And water is what? Molecular weight of solvent, how much? 18 grams. Okay. Now what is to calculate here? Molality. Molality of this solution is what? Molality formula what? Molality formula. Molarity is equal to weight of solute by gram molecular weight of solute into 1000 by weight of solvent in grams. So it is weight of solute. Weight of solute is given how much? 3.42. Gram molecular weight of solute is 342. 1000 by weight of solvent how much here? 250 grams. So molality they asked here. So 0.04 molal. Okay. This formula to be applied. And next one. An aqueous solution of methyl alcohol CH3OH. CH3OH methyl alcohol gram molecular weight how much? Gram molecular weight 12 plus 4 hydrogens now 4 plus 1 oxygen. So it is gram molecular weight. So 16 plus 4 plus 12. It will be gram molecular weight. And contains 48 grams of alcohol. 48 grams of what is there? Alcohol is there. Alcohol means what? Ethyl alcohol. C2H5OH. C2 means 12 to the 24 plus total how many hydrogens? 6 hydrogens plus 16 oxygen. It will be gram molecular weight of ethyl alcohol. Now the mole fraction of alcohol is given. Mole fraction of what is given? Alcohol is given. When alcohol mole fraction is 0.6, alcohol mole fraction is 0.6 here. Then what will be mole fraction of this methyl alcohol? 0.4. Then mole fraction of methyl alcohol CH3 OH will be equal to 1 minus 0.6. That equals to 0.4. A mole fraction of methyl alcohol is given 0.4. Okay. And now what we have to calculate here? The weight of water is what? The weight of water means weight of water is equal to what? Okay. The mole fraction of alcohol is given this one. Okay. Oh yeah, alcohol means methyl alcohol. No, methyl alcohol already we have taken this one. Methyl alcohol means CH3OH only. CH3OH gram molecular weight is this one. And methyl alcohol mole fraction is 0.4. And it is mole fraction of alcohol is given to you already. Just wait. So what is given here? Alcohol means methyl alcohol only take here. So what is the formula generally? Mole fraction of methyl alcohol plus mole fraction of water must be equal to 1. Na? Now here alcohol mole fraction how much is given? 0.6 given. 0.6. Now mole fraction of water anyhow 0.4. Now okay. Now mole fraction of water alcohol is how much is given? 0.6 is equal to what is the formula? Mole fraction, number of moles of methyl alcohol, number of moles of methyl alcohol divided by number of moles of methyl alcohol plus number of moles of water. Again, number of moles formula what? Weight by gram molecular weight. So what is the number of moles of water here? Weight of water by gram molecular weight of water. Weight of water we have to calculate. Gram molecular weight of water is 18 below. And here also weight by gram molecular weight. Weight of methyl alcohol by gram molecular weight of methyl alcohol. So we have to substitute what the given values and we have to get weight of the water. And it is given what mole fraction of alcohol is given 0.6. Na? So 0.6 is equal to number of moles of methyl alcohol. Number of moles of methyl alcohol given what? Given weight is what here? 48 by gram molecular weight. Given weight is given there here. 48 grams alcohol is given. And gram molecular weight will be 12 plus 4 plus 16. So 16 plus 4, 20. 20 plus 4, 12, 32. 32 is what? Gram molecular weight. So it's gram molecular weight 32. 48 by 32 will be number of moles of methyl alcohol. So only number of moles of water we calculate first. After that, number of moles of water is equal to weight by weight of water by gram molecular weight of water. So weight will be now 18 grams. This formula you apply. Take screenshot if you want. Next one, 4 gases like H2, helium, methane, CO2. Henry's law constants given here. So now what they asked here, which is more soluble? Which is more soluble means here third one. Third one is 1, 2, 3. So third one is less here. CH4 has less KH value. When Henry's law constant is less, the solubility will be more. More soluble means less KH value like this. And for an aqueous solution of the same solute, okay, in terms of concentration, 1 molar concentration is greater than 1 molal. Molarity will be more than molality. 1 molar solution will be greater than 1 molal solution. So molarity will be greater than molality. In case of molality, what we define? 1 mole in 1 kg we take. Molarity, what we take? 1 mole in 1 liter. 1 mole in 1 liter concentration. Here 1 mole in 1 kg is this one here. So 1 mole in 1 liter solution here. 1 liter solution. But here 1 mole in 1 kg solvent only. 1 kg solvent only. Remember. So based on this concept, 1 molar concentration will be greater than 1 molar concentration. Okay. Next, the normality of 10% weight by volume acetic acid is. Acetic acid formula what? CH3COOH. For this, gram molecular weight is equal to gram equivalent weight is equal to how much here? 60. CH3COOH gram molecular weight, gram equivalent will be 60 here. And 10% weight by volume. Weight by volume means what? 10 grams in 100 ml. 100 ml solution. So 100 ml solution contains what? 10 grams. So weight of solute is given, volume of solution is given here. Okay, normality formula what? Normality equals to, normality is equal to weight by weight of solute by what? Gram molecular weight of solute. Normality is gram equivalent weight. Gram equivalent weight into 1000 by volume in ml. Volume in ml. So here weight is given 10 grams. 10 by 60 into 1000 by volume is given 100 ml. Like this we take normality. So normality 1.7 normal. Next, an LPG cylinder. LPG cylinder means constant volume. Constant volume. Any cylinder, if it is given, it should be taken constant volume system. So volume is constant. It contains 50 kilograms of butane. How many? So mass is given. Mass of butane is given 50 kilograms. And it is M. Mass is given M. Okay. Butane. Butane formula what? C4H10. C4H10 is butane gas at 27 degrees Celsius. Capital T is what? 27 plus 273. Kelvin. Okay, 10 atm pressure. So at my initial pressure is what now? Initial pressure is given 10 atm. Initial temperature T1 is given 273 plus 27. After that, mass is given what? 15 kg. 15 kg means 15 into 1000 grams. And it was leaking, and its pressure fell down to 8 atm. So finally, pressure became what? P2 became 8 atm. Okay, atmosphere pressure for 1 day. The gas leaked is how much? The gas leaked means the difference we have taken. How much gas is leaked? Initially, how much mass is there? Finally, how much mass is there? In this case, now here, PV is equal nRT. In place of N, what we can add now? Mass by gram molecular mass. Mass by gram molecular mass. Okay. Now, mass if we take this side, so P by M. P by M is equal to R T by molecular weight. And constant volume, I said, na? Cylinder means constant volume. And molecular mass will be constant value. R is constant. Temperature is constant. All are constant here. So P by M should be taken as what now here? Constant. So P by M should be taken as constant. This total is equal to